is going to be distortion. Okay, so two things which is very, very important for an amplifier is, one is it should provide a very high amount of gain. Second one, it should provide a noise-free, distortion-free output. Noise can come from external sources, noise can come from internal sources also, but distortion will come purely from internal only. When the device is not biased properly, it will produce distorted output. So my aim is to ensure that whatever parameters are going to change outside the device or inside the device, my active region should not change in my transistor. That is why I'm going to go for all these biasing circuits. The biasing na another, what voltage if I give, what resistors I additionally put to my BJT will be always functioning in the active region. So those resistance and voltage sources, if I form a circuit, that circuit is called as biasing circuit. Okay, so see here the voltage and resistance which have to establish these two things in a transistor. So you have to have a constant voltage across the collector emitter junction, and you have to have a constant current across the collector flowing to have the transistor in the active region. See, output you take from collector, right? So in collector side, what is the voltage you have? You have collector emitter voltage, because we'll be discussing about common emitter amplifier only throughout. Okay, so emitter is grounded. So output side, what are the terminals I have? Collector and emitter. So the voltage is VCE, and Q indicates the quiescent point, and output current is collector current. So ICQ indicates the quiescent point. Other currents is IC, other voltage is VCE, but exactly at the Q point, the voltage becomes VCE, you add an additional Q, and the current becomes IC, you add an additional Q. So when you have these two parameters in the device, you can say that the transistor is working in the active region. So I told you, right, Q point will have two parameters, X comma Y. One is voltage, one is current, right? So this voltage is going to be VCEQ. This current is going to be ICQ. Okay, so this, if any use this coordinate value, you can clearly say whether the transistor is working in active region, or it is working in cutoff region, or it is working in saturation region. You can clearly identify from the Q point. So these two values, voltage and current, if you properly write in the form of a coordinate system, you get what is called as the Q point. The Q point is also called as quiescent point, or it is called as the operating point of the transistor. Okay, so these two parameters, VCE and IC in general, they determine the Q point of the transistor. At Q point, you write them as VCEQ, ICQ in a format like this as I shown here. Instead of X, you have to replace by VCE, and instead of Y, you have to replace by IC. Okay, so these will determine the operating regions of your transistor. So as I told you already, we are not going to worry about cutoff or saturation. We are going to focus only on the active region of your transistor. So for these providing this exact coordinates for the transistor, I need additional external circuits called power supply voltages. I need resistances for obtaining this Q point. So that is why I am going to call the circuits going to be called as biasing circuit. Power supply, okay, it is required for functioning of your transistor, correct? Because without power supply, your BJT will not work, because BJT is a passive device, right? Why do I need resistance here? Why cannot I use inductor or capacitor for biasing? Why do I need a resistance for biasing my BJT? Can anybody guess the reason why I'm going to use resistance for biasing the BJT and not inductor or capacitance? Any guess?